So we're going to give a talk today on better smart contracts with behavior-driven development. My name's Neodaoist. Yeah, come on in, guys. Grab a seat. We're just getting started. Hey, how's it going? My name's Neodaoist. I'm a software dev, Solidity dev, product person, working on a DeFi protocol right now.
And I'm Petrotech on Twitter. You can call me Pete. I've been working on software for about 20 years, Web 1, Web 2, now Web 3, and using behavior-driven design in many projects across many different areas. Okay, let's get started here. How many of you principally write code? That's what you do a lot, okay? How many of you always or almost always write tests with your code? Few, okay. Now, we're at a Ethereum conference here and you're at a talk on testing. So put your hand down if you're the only one on your team that writes code, or that writes tests with your code. So this is the problem. This is the problem we're trying to solve. Get everyone on our team, everyone who's writing code, to write quality tests. Some agenda of what we're going to talk about. We're going to talk about the what and why of BDD, transition into some BDD mechanics, and then we'll talk about BDD as a tool within your larger toolkit.
Nice. So starting off with what is BDD, so behavior-driven development. Ultimately, what we're going to have is a plain English executable specification that describes how our system, in this case our smart contract or our Solidity code, should work. It's going to evolve alongside our design and implementation and our documentation, and so we'll see some examples in a little bit. One thing you might hear in this kind of BDD world is it's a token for a conversation. This isn't some type of like product requirements document, PRD spec that we're trying to write that can like save us from having to talk with our users and our stakeholders. This is a token for a conversation. It's kind of a placeholder, and it will help us remember what we've talked about and really describe it in an unambiguous way. So it ties all behavior that we're going to write in our smart contracts or our broader system to a user and a purpose. So we know why we're writing any piece of code. I kind of mentioned this. It's going to help us express complex functionality unambiguously, but in a like human readable, friendly, approachable way. And finally, we think this has a lot of value, particularly in an environment like an adversarial environment like the EVM, and when we're doing immutable one-way deploys, a little bit more akin to some of the properties of hardware development, and that's where we think this kind of rigorous way of writing a spec will be really helpful, and we're going to share some of what we've done with like half a dozen projects or so far.
Okay, let's get into some mechanics of how BDD looks in the real world. We'll introduce a few terms here. First of all, BDD, what are we talking about here? Behavior-driven development. This is a framework for specifying a software system that ends up being executable code that you can understand. So it's user stories illustrated by examples. Cucumber is a framework that implements BDD. It was originally developed by Dan North quite a long time ago now. Implements BDD by executable feature and scenario specifications. It was originally developed in the Ruby world, but it's been ported to many languages, including Java, but more appropriate for smart contract development, JavaScript, Python, and Rust. Gherkin is the language of Cucumber, and we're going to be seeing some examples of that in just a second. It is specific enough to be executable and to be useful to a developer, but it's natural enough to be understandable by non-technical people. That's what makes it a token for a conversation, and you'll see how that works in just a second. So we have features, scenarios, and step definitions. A feature is a desired product functionality that we're going to illustrate with scenarios. It always involves a user who's trying to do a specific thing. It's a sort of like a user story, but a little more specific. A scenario is an illustration of a feature. It takes you through one particular path as we try to understand what a feature looks like, and it uses formal steps and examples. And then a step is a definition using this given, when, then pattern that's become quite common in many test environments that illustrates the scenario. So BDD is important, even if you're in the habit of writing unit tests, and you write great unit tests. We need to go a little bit deeper for an application. Here we have an example where we have two unit tests. This outlet works fine. The towel bar works fine. They don't work together in a way that satisfies a user. So we need to integrate our system together and test the whole before we can be confident to release it to end users. Let's take through an example, a very simple example of minting an NFT. So this is a project called SporkStar. It's something that we're actually working on for ETH Denver here, and I'm not going to describe it for you. You'll see it in the code here. So as an attendee of ETH Denver, this is the who. All features ultimately come back to a human. Even if something is quote-unquote system, there's always a human at the end of the pipeline somewhere. Maybe it's an administrator, maybe it's the contract owner. Try to figure out who the human being is that we're trying to do something for here. Why? In order to have a memento of my experience and people I met. What? I want to mint a SporkStar. Now we have a framework in mind of a feature we're trying to build, why we're trying to build it, and who we're trying to build it for. So here's a happy path, minting a SporkStar using USDC. So now we're going to get into the given when then pattern. So givens are the situation in our system. Smart contracts are state machines, so a state machine, before an event takes place. So given I have 5 USDC in my wallet, when I mint a SporkStar, then I should have a SporkStar in my wallet, and I should have 0 USDC in my wallet. This is not super complicated, but it illustrates the idea of how this works. Let's look at a contract that many people are familiar with, wrapped ETH. If we were writing the specification for wrapped ETH, it might look like this: feature wrap and unwrap ETH. As a Web3 user about to interact with the dApp, in order to use ETH in contexts that require an ERC20 token, I want to wrap ETH in an ERC token, and then I want to redeem that back to ETH. Deposit, what's this look like? Given Alice has 10 ETH, and Alice has 0 wrapped ETH, and the total supply of wrapped ETH is 50. When Alice deposits 2 ETH into the contract, then Alice should have 8 ETH, and Alice should have 2 wrapped ETH, and the total supply should be 52. So I'm going to pause here and ask, how many people here describe themselves as non-technical, not developers? Well, we should have had some developers come to this talk, but those that are non-technical, keep your hand up if you kind of understand what's going on here. And that's the point of this, right? This is specific enough that if you're a developer, you can make this work, turn it into a real-world test. But if you're having a conversation with someone who is not technical, they can also understand what's going on. And that's the beauty of this particular Gherkin language.
Nice, thanks, Pete. So a little bit about how much to automate. And we were kind of thinking about this, about Web 2 and Web 3 projects that we've worked on. There's a few different levels to this. So level 0, it's like just write the feature file, have the conversations, do the thinking. You know, often you'll be writing a feature file, you can revise it. We're going to talk about how words and pictures fit together a little bit later, but it's basically just writing your spec in such a way together and co-creating it with your users or your teammates or your stakeholders. So that would be great right there. That would be level 0. Level 1 would be basically write your feature file and then write, so we're Foundry Forge fans, write Forge tests. And we're going to see a sneak peek of how GitHub Copilot and other AI tools can help this. This isn't like the most driest way to do it, right? Because if I have a feature file and then I have a separate set of like a Forge test suite, when I make a change, I'm now having to update it in 2 places. But it's a pretty good way to structure your tests, to be sure. Level 2 would be fully automated Cucumber step definitions with like, we've done Cucumber RS plus Ethers RS, and so we'll see an example of that. You could do Cucumber JS plus Ethers JS, or hopefully soon we could do Cucumber Solidity or some such thing where we have Cucumber feature files that are being driven by Solidity code itself, so we can define our steps in Solidity, and we don't have to context switch to another language. So yeah, let's see an example of like what level 1 could look like, where we're writing this feature file and some Forge tests, and then we'll see level 2 also, where it's fully automated with Ethers RS.
Okay, so now let's imagine we're in an IDE. This is in our Forge test file. I've cut some of the boilerplate, some import statements and things like that out so that you can actually see it on the screen. We're going to go through the same scenario that we just saw, minting a SporkStar using USDC, and actually implement this and turn it into a real test. So we have a function. This just looks like any other unit test framework, test mint SporkStar for USDC, and we're going to start implementing this. Now at this point, for this level 1 type implementation, we're not using a robust Cucumber framework. We're just using Forge. So what we're literally going to do is copy and paste our given when then specification into this Forge file and start implementing. So our first given was, given Alice has 5 USDC in her wallet. Now we think, well, all we have to do is think about this specific step. What does that mean? How do I make sure that Alice has 5 USDC in her wallet? Well, in Forge, we would start prank, so we're going to act as this address, and we're going to use this utility function, write token balance, to put 5 USDC in Alice's wallet. I should mention at this point that we're running in a local test environment, a fork of mainnet, but this is happening locally, which is also why we're ignoring gas fees and other such things. When Alice mints a Sporkstar, what does that look like? Well, we have to approve on the USDC contract, and then we call this method on our contract, mint for USDC, passing in the token ID that we're minting, our address that we're minting to, and the amount. In this case, this is also, I should mention, it's an ERC 1155 type token, so we're minting one of token ID 1. Then Alice should have a Sporkstar in her wallet. What's that look like? That looks like an assertion. We assert that our has token method with Alice's address returns true for token ID number 1. I should also mention at this point that GitHub Copilot turns out to be really good at this. By the time you paste these comments in here, you're given when then, about 80% of the actual test code can just be generated by AI. It's a huge time saver in writing test code. Okay, last step, again, something that GitHub Copilot generates just fine. We assert that Alice now has 0 USDC in her wallet. So now we've gone from the specification to a unit test that we can actually run, we can actually put in our CI pipeline, and now we're asserting that our smart contract behaves the way we agreed with our user that it should behave. Last step is payout address should have 5 USDC. Where did that USDC go? It went to our payout address. Now we're going to take a look at a slightly more complex example. This is a project we did that has a random reveal mechanic, so a series of NFTs that reveal their particular tier of rarity after some time. So here we're using a little bit more advanced syntax of Cucumber, but the same idea. We're going to focus in on when we reveal the art. Then there should be 222 tokens with the following metadata and quantities. The key thing here, well, really, we have tier descriptions, we have the rarity. These are attributes that end up being set in the NFT. In this case, the quantity is the key thing here. So we reviewed with our client, what are the quantities you want to have in the case of a sellout? They came up with these numbers. Let's make sure this actually works. And then also calling reveal a second time should not change any tiers. This is immutable once reveal has happened. So in this case, we used Cucumber RS to implement this in Rust code. First, we have to set up a few things. We're using again, you could, if you don't like Rust, you can use Cucumber JS and do the same thing in JavaScript, or Cucumber in Python. If you're writing Viper code, you can do the same thing in many different languages. This happens to be Rust. So we have to do some setup here. We have to set up our fork environment, and then this ABI gen macro is generating Rust bindings for our smart contract that we can then interact with in our Rust code. So we're setting up our fork network, setting the chain ID, and running the rest of the scenario. This is a step def, so this uses a macro that matches our when pattern. So when, and this matches the we reveal the art. This tells the Cucumber framework, this function matches this step def. So when it's running through our feature file and it sees we reveal the art, it's going to look for some function that's annotated with a regular expression that matches that step. Here it finds this one, it's an exact match, so it's going to call reveal art. It's going to pass in this world object, which is something that the Cucumber framework maintains. You can use this to store state between your step definitions. So in this case, we've deployed our contract in the setup step, and we've stored that contract reference in the world object. Cucumber passes this into each step def so that you have this context as you go through the steps of your scenario. So in this case, we're going to call the reveal method on our contract. Now this is where you see why we're doing this in a rich language like Rust rather than trying to do this in Solidity. So this is matching, again, a regex. The distribution should be so many ultra rares, so many rares, so many uncommons, et cetera. And what Cucumber does is it passes our world object in, and then it passes in each pattern match of this regular expression as parameters into our method. So we get the number of ultra rares, the number of rares, et cetera. And what we're going to do is we're going to call our contract method. We're going to use a range operator here. Luckily, this is a local test network, so we're going to call our contract method 222 times, but it executes extremely quickly. We're going to check the tier info for each one and sort it out and check that it matched our expectations. Another useful feature of Cucumber is the idea of a scenario template. So in this case, we had this conversation. What happens if we don't sell out? What happens if our supply isn't 222? What if we only sell 50? What if we only sell 100? We had this conversation with our client, and we agreed how the distribution should work for any particular number of sales. One of the things that happens here is we always have one in each tier. Now what Cucumber does in this case is it's actually going to execute this scenario one time for each row in this examples table. So we're actually going to run the scenario 6 times in this case, passing in these parameters. The nice thing about Cucumber is you can actually reuse step definitions. So you see the when we reveal the art and the then methods are the exact same thing we did in the previous example. I already wrote the step definitions for that, so I don't need to write them again. Cucumber will find that, and it'll pass in these parameters. And now we've done a very robust test. Again, local forking. We're forking, we're deploying 6 times, we're revealing, and we're checking, and this still executes in a couple of seconds.
Nice. Okay, so we're talking about BDD. That probably brings to mind TDD. Do you really have to write your tests first? Well, I don't know. How many people here do write tests first, at least some of the time? All right, some hands, some, yeah, some maybes. So I would say, like, no, but don't get too far ahead of yourself, right? Bugs live in untested code. The more source that you write untested, if and maybe inevitably when you run into an issue, it's more to untangle, either to like debug or make the code testable. So don't get too far ahead of yourself. And where does confidence come from? So when you're refactoring under green, like under tests that pass, you change some of the code and all of a sudden you have a failing test. Then you start writing tests and then you start adding the new functionality. That's a really good feeling. It's a great feeling. The other day, working on a contract, I changed from like kind of a naive, like 1-step ownership change to like a 2-step pattern where you nominate a new owner and then you accept it. I made that change like a TDD style. It felt really good because like I had a set of like happy path tests that had to change, or like 1 or 2, and then some sad path tests for all the ways that it could go wrong. Felt really good that now I had tests that asserted that behavior and that I was as confident as I could be, I think, that I implemented that feature correctly.
Just to put a finer point on that, though, you should write your test first, but sometimes we don't. Sometimes we're in the code, we've really written a lot of tests, and now we find out, oh, I needed an only owner attribute on that method. You can put the attribute in and then immediately go put your test in. That type of thing is okay. That's what we mean by don't get too far ahead of yourself. What you don't want to do is have 100 lines of code, and now you go to write a test for it, and you can't even remember what code you've written. Something breaks, and now you're not sure what broke because you've changed 6 or 7 different things. That's the point.
Totally. And yeah, afterwards too, I would be curious to hear people's experience both writing tests first, writing tests later, hopefully not writing tests never, but not every software problem probably requires it, but I think there's a lot of benefit, and that's kind of what we're trying to espouse today. Okay, so this is not a silver bullet, right? This is a tool in your toolkit, and we're going to show some show how it fits in our toolkit, because as Solidity devs or EVM devs, there's a lot of different things that we need to do to ensure that the smart contracts that we're writing, particularly if they're going to be holding user funds, are as airtight as we can so that we can sleep well at night, so that the auditors are happy with what we present to them so they can audit our code the best that they can, and ultimately we solve a user's problem at the end of the day. So fitting in with your CI stack. One thing is, if we think of kind of a testing pyramid, at the bottom, unit tests, probably more of them, but they run a lot faster. As we go up, we might start forking mainnet. We might start integrating more with actual contracts that are deployed. it's pretty nice. So you can see in this project, we've got some GitHub actions like unit tests, then the Cucumber tests, then code coverage type stuff. It's pretty nice because we can see with a well-named scenario, if we were to break something, hey, what broke, what part, and we can see that if the build fails. So it fits pretty nicely with your CI tests, to be sure. Having these as different jobs is kind of nice too, because the longer running ones, like maybe not Slither, but something that takes like a really long time to run, you can have later, so you can fail the build early if there is actually something wrong with it. So one thing that I maybe wish that some of the BDD community, if you will, would focus more on is pictures. You know, we know the saying, pictures tell 1,000 words. There's something that a picture can really express and communicate and help build shared understanding between me, the users, and stakeholders that just straight words or prose, like we've seen with these feature files, won't do. So a user story map, great way to express this functionality. If we want to really get more specific with how state changes, maybe we could use a sequence diagram, some type of a process flow diagram, maybe UI comps if there's a big user interface element. It dovetails really nicely, we found, with these BDD feature files. Invariant testing, shout out to Horsefacts for this great repo where it talks about WETH invariant testing. But this can fit really well, and we'll actually have a feature request, I guess, for Cucumber to be actually define invariants inside the feature file, which I'll show a sneak peek of. Threat modeling, shout out to Zelik who produced this threat model for Valorum, a protocol that I'm working on. But the idea of really explicitly saying what every function does, the happy and sad paths, and then the controllable inputs and all that type of stuff, it can fit really nicely with the unambiguous nature of this Cucumber specification that we're writing. Okay, and then finally, just putting my product manager hat on for a moment. I don't want this to come across, we don't want this to come across, that you can sit with a user, ask them what they want you to build, write it up in Cucumber, write a smart contract, write a dApp, ship it, and then you've solved their problems, right? Like, at the risk of sounding cliche, we've probably heard that Henry Ford quote, if he asked users what they wanted, they would have said faster horses. Users are experts in the problem, not in the solution. It's our job as developers and builders to be aware of the technology that's just now becoming possible so that we can solve the problems that users come to us in novel ways that is a better solution for them. So I would be remiss if I didn't mention this at the end, that it's a continuous discovery process of user interviewing, rapid prototype testing, and other things that help us get to the confidence level that we're actually going to be solving their problem. And Cucumber can be a great way to actually articulate what we're ready to build, particularly what we're ready to build when it's going to be a one-way, immutable, hard software deploy.
Real quick on that point, sometimes when you're writing a feature file, it forces you to think through a problem, and you realize you don't actually know how the behavior should be. You're getting ready to talk to your stakeholders. In that case, put a question mark. Given something, when something, then, I don't know, question. And then when you're reviewing that with your stakeholders, it prompts you to talk about that. You say, what should happen here? Let's talk about it, let's get it captured. Now you captured it in your feature file, and now you remember that you talked about it.
Nice. Okay, cool. So some benefits and costs to automation, because we're talking about probably, maybe for some of us, doing things and spending time that we aren't doing today, so there's a cost to that. Let's talk benefits. Better CI, we think it can be valuable fitting into your CI pipeline. Step reuse, so I'm sure there's like unit testing patterns that we use where we have, whether it's composition or inheritance type stuff to save common things that we're interacting with our contracts and our tests. Like you showed, Pete, some things run richer expression, both in plain English and then verification with some nice data structures. You can refactor with confidence. There's nothing that would stop you from writing this kind of given, when, then style just in your unit tests. Honestly, that's super valuable. I've done that for some projects that don't have a lot of like end-to-end feature testing requirements. That's great. And then catch bugs and design flaws early, hopefully before sending to the auditors or before shipping.
Okay, but is this for free? Well, no. There is some initial upfront cost. You have to set this up. There's some ongoing maintenance cost. You have to maintain your test. And currently, it requires context switching to a language with native Cucumber support like JavaScript or Rust, where we're not writing our smart contract. However, in every project I've ever used behavior-driven design in, and I've been doing this for at least 10 years, those costs have always been amortized by the time we ship the first time. In other words, it actually, over the course of getting your product out in the marketplace, solving problems for real people, it accelerates.
Nice. So a couple, or a few wish lists that we have here as we're winding down our talk today. So connecting to Foundry, this would be amazing if we could write our step definitions in Solidity, so we can drive automation, basically interpret the Cucumber file, run forge tests, and then we don't have to context switch, like except for like plain English and Solidity. That would be amazing. Let's make it happen. I know there's some Rust gigabrains in the audience that can help make this a reality. Invariant hooks. So this would be an idea where we could write our invariants in the Cucumber file and get a little bit more numerate with like some math and things that we're trying to keep as an invariant, and then run that before and after every step in the scenarios that we have. That would be amazing. And then this last one, you may have seen that scenario outline. I think we showed a couple. It's like quasi-fuzzing, but if we could have fuzzable scenario outlines where we could exercise boundary conditions and really throw a lot of different random data and random inputs in, I think it would let us express, again, particularly in EVM smart contract world, DeFi, where there's a lot of math and numbers in it, we could then fuzz from our Cucumber files, which could be a great way to express it. So I think we have one more side. Quality is a first-class citizen. Let's treat it as such. So thank you. So, yeah.
So I'm going to leave you all with a challenge. I went to a conference maybe 10 years ago on Cucumber, and the speaker gave this challenge. I'm going to pass it on. Try this. The next project you do, just take on faith that this works. Try it for one project. If you don't like it, if you hate it, don't do it again. Try it end-to-end on one project. See if you like it. I took that challenge, and I will never do a project without BDD again.
Yeah, and connect with us on Twitter. And yeah, any questions, comments, or ideas? I think we have a few minutes left.
Thanks. Another BDD jargon term, but as you're building these projects, are you doing something like outside-in red-green refactor with your tests? Like, can you describe just a little bit how it benefited you in the relationship between your integration tests and your unit tests?
Yeah, totally. So the question is about the kind of outside-in red-green refactor loop and how that can work for integration in unit tests. Well, I'll give a good example. So in the hackathon, I'm working on a. I guess we can leak this. Working on a game. We'll just say it's a game. And when I'm sitting down to write the source code, what I did initially was write some given, when, then features to say, okay, so this is the scenario that I'm trying to do. Then I went over and wrote a failing unit test, wrote some Solidity code, wrote another failing unit test for the revert conditions, expect revert in Forge, wrote the Solidity code with the custom errors, and did this a few times. Then I could zoom back out. So we actually had a good graphic in another presentation we've done of this, where there's two loops. There's a big BDD feature loop where we write a failing feature test. Then there's a smaller TDD loop where we write a failing unit test, make it pass, refactor, write a unit test, make it pass, refactor, and then we finally zoom out until we've implemented enough functionality for the feature. Then we write our next failing scenario. We go in, we do the red-green refactor loop for the unit test, and then we zoom back out. And so just doing this locally, and then you can start to see when you open a PR and you have some failing, or you have some passing feature tests and some passing unit tests, it's really kind of building the spec alongside the tests, alongside the implementation. So it's been quite valuable. Any more questions? All right. Yeah, come find us afterwards if you have ideas why this could work, why this wouldn't work, why it would be valuable, why it would be a waste of time. We'd love to hear more. So thanks again, everybody, for coming out, and have a great conference. Have a great...